Emojis are a youngster's language. I get it. It's not fun. Huh? It's good. Yeah. Only somewhat. Yeah. Oh, that's good. Yeah, I on phone. You left your sorry. I was late with the bus. Permanently mean this divided by this. Well, extremely big network has position. Yeah, I would say. Oh no. Yeah, I looked at the bottom of it. Chocolate's here. I'm not caring.
Just 2 minutes, 1 minute. Jackson.
All right, good morning, guys. So last time I saw you, we started off with section 3.4, which was solving the exponential and logarithmic equations. And we had a lengthier book assignment there. Aaron, wait for me, please. We had a lengthier booked assignment, and I told you didn't have to worry about doing that for homework yet. So that is actually the second big thing on our agenda today. Give you some more class time to do that. But first, since we've now gone all the way through 3.3, and we've talked about 3.4, and you've gotten some practice on 3.4, I actually have 2 practice quizzes for you. So I'm going to give you one of them today, and then I'll give them one of them on Thursday, and then this quiz will be on Friday because this is a B week. So what I'd like you to do is to really treat it like a practice quiz so that you get some real feedback about where you stand. So I suggest you do it without hints from your neighbor, without your notes, and without a calculator, because all of those things might mislead you to think that you're more prepared than you are. And again, we got today, we'll have all the class on Thursday for one more practice quiz before we get to the quiz on Friday. So it's fine if you've got some mistakes or some things that you need clarification on, but I think it's a good time for you to go ahead and try a practice quiz and kind of see where you stand. So I'm going to set a 30-minute timer for that. I think that's probably a little more than you need. You're probably either going to get stuck or finish before then, but that should allow everyone plenty of time to try that as a practice quiz. And then since we have plenty of class time, I will go over the entire practice quiz with you. And of course you can pay attention to the questions that you missed. I've got the solutions on my website if you want to check them earlier. And then you can have the rest of class to keep practicing through the book assignment that you started last Thursday. So, any questions about the plan for today or this week? Okay, so do your best to try to finish up these, 10, 12 questions in 30 minutes, please.
That makes that choice that you could circle one. That's what I want, hopefully we should catch. But we're gonna go over it, we're gonna figure it out.
Okay, just about 3 more minutes, and that timer will be up. I'll start going over all of it. So hopefully that was enough time to let you try that out and at least see where you slow down and start to see which ones you need to give some more attention to. Again, it's not super critical at this point because your quiz is still not next class, but it should help you identify some of the stuff that is going to require a little bit more attention here. Now, of course, I highly suggest that you circle the questions you make a mistake on, maybe write yourself a note or two, try to summarize the things that you need to know that you need to get out of this so that you can do better on the second practice quiz I'll give you on Thursday. So what I'd like to do is go ahead and go through all of these questions, and then I'll give you guys a chance to tell me if there's any of them you want me to go back over, or you have clarifying questions or anything like that. Okay, so question 1 wants us to know the change of base, and change of base answer could be written 2 different ways. It could be written with common logs, which is base 10, or it could be written with natural logs, base 3. It's important that you know both because the first few questions on your Friday quiz are also multiple choice. So if you only know this way and we write it like this, then you may not get the answer right. If you only know this way but we write the answer this way, then you may miss it. So A was the only one that would have worked. Again, I'm going to go ahead and keep, instead of pausing after every question that asks for if there's anything you want to speak up about, I'm just going to go through all of them and then I'll give you a chance at the end. Okay, the next few questions are about 3.3 and expanding and condensing. So in question 2, your first real challenge should have been dealing with this square root. You cannot just pretend like the square root's not there. I mean, you might get lucky and accidentally put it in the right spot, but really you should change it to an exponent. Square roots are the same thing as an exponent of a half. And that allows us to get it out of the way because now it's an exponent on something I'm taking the log of, so that exponent can come down out front. Okay, and now I can do the expanding. Log base b is going to expand into 2 log base b's. Since they were separated, or it was division inside the log, it's going to separate as subtraction. 77 came first. It's its numerator, so it comes first. The denominator comes second. Should have been aiming for that. None of that's going to simplify. Looks like choice A again. But again, if you are not changing that square root into an exponent, bringing it down and getting it out of the way, then it's hard for you to know where's this 1/2 supposed to be. Is it still supposed to be a square root? You need to deal with that up front. Alright, next 2 want us to condense, and there's only 2 ways to condense. So you can either condense addition with multiplication, choice D, or you can condense subtraction into division. Now, this one doesn't look like the answer is there, but that's because 35 divided by 7 reduces to be 5. So, you need to know both ways to expand, both ways to condense. Those 2 were about as straightforward as we could make those. Alright, so 5 is also an expansion, but this one has a little bit more stuff going on with it. And I think your second practice quiz will have another one of these, and this is one of 2 questions I ask you to do as guided practice on your notes, because this is a very common question type. So once again, division inside can expand as subtraction. One thing that makes this question a little bit harder is that this expands a second time. Since these 2 were being multiplied, I could expand these 2 with addition. Multiplication becomes addition. And if you're going this way, you should bring down the exponents as coefficients. And notice one of the answers is what I just did. That would be B, but that is not the correct answer. So this is what I tried to emphasize a lot on your notes. And I honestly don't know if it's on this year's quiz or not, but it probably is, because this is a pretty common question type. If you picked B here, what you didn't think about was right here. This was minus all of this. So when you expand it, it's still minus all of it. It doesn't just magically somehow become minus the first part of the expansion, but add the second part of the expansion. It's minus the whole thing. So your answer needs to either have parentheses, or you need to distribute that negative. So if you got B, what you had wrong is this symbol here had to be a minus. You had to distribute that. So that had to be C. Again, subtract this whole thing. Even after you condense it, it still subtract the whole thing. Make sure you put in parentheses so you don't forget that. Okay, and then on the back we've got one more condensing. So this kind of summarizes what you should know about 3.3. So before you should condense, you should bring this 2 up as an exponent, bring the 4 up as an exponent, get them up out of the way, and then subtraction is going to condense into division. X squared comes first, so it's the numerator. X plus 2 to the 4th comes second, so it becomes the denominator. That looks like that is choice B. Alright, so since I know there's a couple little nuances about moving the numbers around depending on which direction you're going, but 3.3 is not usually too much of a challenge for people, because at the end of the day it's, I guess, change of base. You could consider that as 3.3. 2 ways to expand, 2 ways to condense. But 3.4 takes a lot more practice, and this is why we are still not quizzing on Thursday. We don't quiz till Friday, because 3.3 takes more time for it to click than some of the other stuff. Now, I'm actually going to do these out of order because some of these questions are very similar to each other, and then there's a couple that are a little bit different. So when I'm thinking about this 3.4 stuff, I'm specifically thinking about how I structured it in the notes. There was a couple questions we could do in our head. Most questions we could switch to form, exponential to logarithmic or logarithmic to exponential. Sometimes we had to factor if it looks like something. Sometimes we have to expand or condense to start off. And sometimes we had to take the log of both sides. Oh, and oftentimes we had to undo, add, subtract, multiply, or divide at the start and or end of the question. So most of the questions are going to be like number 8, where you can undo, add, and multiply. Do the easy stuff first, but at some point you have to do a logarithm step. If you're solving an exponential equation or a logarithmic equation, you're going to have to use some kind of logarithm property. And what you need for this, and I think you needed this on all 6 of these, if I remember right, switch the forms. This is exponential form. This is his equivalent logarithmic form. Now, I'm not going to take off on the quiz if you say log base e of 15, but just so you guys know, if you always write it that way, people are going to think you don't know what you're talking about. Log base e just means natural log. So I undid a plus and a times at the beginning, and I still need to undo a times 2 at the end. So one answer, there can be multiple answers here, and I can't even begin to list them all out. But one, and probably the most common answer, would be the natural log of 15 divided by 2. It's not the natural log of 15 over 2. It's all the natural log of 15 all over 2. Now, I'm not going to talk about this on most questions just because it's a little time consuming. But when we get to your quiz on Friday, it'll be no calculator. That doesn't mean that you can't check this as an answer though. If this is what I think x is, I could plug it into the original equation, and it's going to look like this, and I hope that it comes out to be 40, because if it comes out to be 40, I did it correctly. But if you plug it in, there's very little you need to be able to do to see if this works. Times 2 divided by 2 are going to cancel. And then this is the last big hurdle. This is one of those properties that you were supposed to know back in 3.2. E to the log base e of 15 is just going to be 15. So you end up with 30 plus 10, which is 40. And that's what I wanted it to be. So now I'm 100% sure that answer is correct. You can't check your answers with the calculator on the test and the quiz because we won't let you have a calculator. We don't want you to try to do it graphically, but you can still check some of them by plugging it in and seeing if it makes the left and the right side equal, like I just did. So again, I'm not going to do that on every question, just know that that's an option that you could do. Okay, let's skip down to question 11. Again, I'm just trying to focus on the ones that all kind of are the same thing. So to me, this one has the same steps. Undo the basic arithmetic, like undo times 9. At some point, like you got to do on 99% of these, you've got to switch the form. This one's in logarithmic form, so you should switch it to exponential form. And to go from x equals, or 3x equals to just x equals, divide both sides by 3. Yeah.
Did you like divide 3 equals like fraction?
Oh, simplify this. Yeah, I could divide this by 3 and this by 3. That's a little bit better. Is that what you were saying? Yeah. Technically, that's kind of weird because I know that you guys should make a habit out of reducing and stuff. And I try to be consistent because I know when teachers are not consistent, it's hard for you guys to not know what to do. But for me, that's not so important if you leave it like this, since these are equivalent. And the reason why I have that philosophy is since I teach the AP Calculus, we make basically all of our tests similar to how the AP test is. It's multiple choice and free response. So as multiple choice, they're probably going to reduce this, but when I don't see my answer there, I'm going to question that and I'm going to see what that is, so I could still do the work. And as free response, they don't expect you to do any arithmetic at all. Like if the answer to something was 8 and you say your answer is 5 plus 3, they'll still count it. They don't expect you to do any arithmetic. So that's where I don't really care if you simplify there. Just make sure that you can if you need to. So in case it was multiple choice. But again, compared to the one I just did, I undid times just like that question. I switched the forms just like the last question, and I undid times at the end just like the last question. I think 12 is very similar as well. Logarithmic form, I can't undo, add, subtract, multiply, or divide yet. I can't get rid of this stuff. It's trapped inside the log. But I can switch the forms, which you can see I'm trying to highlight for you in every single question. And that's really the only thing that's special and unique about this. This is something you've been doing since Algebra 1. Undo plus with subtract. Undo times with divide. And there's your answer. And again, you could always plug it back into the original equation to make sure that it works. But third question in a row where you had to switch the form at some point. So I'm trying to highlight that as much as possible, because if you can't switch the forms correctly and or that's not at the top of your list of things to try, then this part of the quiz and this part of the test is not going to go well for you. Okay, so going backwards here, I would say the next most appropriate would be question 9. Question 9 looks different and it does have a different first step, but then it should be the same as the last 3 questions we did. In fact, if I asked you what you thought was more difficult about 9 compared to the last 3, I think most people would say this one has a fraction. Well, If the fraction is what makes the question seem harder, just multiply both sides by the denominator. As long as you do it to both sides, that's okay because you're keeping your equation balanced. It leaves a 20 on the left and a 5 plus 5e to the negative x on the right. And to me, now it's no different than the last couple questions. I'm going to undo, add, subtract, multiply, or divide, switch the forms, and then undo, add, subtract, multiply, or divide. I could subtract 5 from both sides. I could divide both sides by 5. I need to switch the forms here. Typically though, you guys do better if it's written like this, so you might want to swap these two around. He's in exponential form. Here is his logarithmic form. And then undo timesing by -1 by dividing both sides by -1. Yeah.
I did it a different way. I just set 1 plus e to the negative x to 4. Is that like something I can do every time or no?
Sure. So since 20 divided by 4 gives you 5, you could do that. But where you might have issues is what if we make this 21 and now it's not a nice whole number? So that's where you would be in trouble. But
If I see something like that, can I do it?
oh yeah, that's fine. He just recognized that this denominator has to be 4 because 20 divided by 4 is what gives you 5. So he just set the denominator equal to 4 and went from there. But again, the first step's a little different. Just get rid of the fractions, and then it's the same as the last 3 questions. I undid add, subtract, multiply, or divide. Undid add, subtract, multiply, or divide. Switch the forms. Undid add, subtract, multiply, or divide. But switching the forms has now come up in 4 questions in a row. Okay, I think the next most appropriate one is number 10. So I can't undo, add, subtract, multiply, or divide yet, and I can't switch the forms yet. It's not in the right forms, and there's no basic algebra to be undone. So this is a large part of why we even do section 3.3. This and this are both log base 3's separated by add or subtract, which means that you could condense them. Condensing on its own is not that terribly useful of a skill, but the fact that it allows us to be able to solve even more equations like this one, now it's similar to the last 4 that I did. There's no basic algebra to be undone, but it is in exponential or logarithmic form. I could switch it to the other form, multiply both sides by an x, take away an x from both sides, and divide both sides by 26. So lots of undoing, add, subtract, multiply, or divide at the end. But if you don't consider condensing to start off, or you can't condense correctly, then there's not much else you can do on that question. There's not anything creative you can do that's reliably going to work. Condense, switch the form, solve normally. Okay, so I think that leaves us with one more. Now, I purposely skipped this one because it stands out a little bit different than the others. But I know what has been working, so that's what I'm thinking of in my head. I'd love to undo, add, subtract, multiply, or divide. I guess you can add the 8 over, but that doesn't help. You're just going to move it back anyway. I know switching the forms has been very common, but this is not in either of the 2 forms, so that doesn't make sense. There's no fractions like I did in number 9. There's nothing to condense like I did in question 10. At some point you have to say all the normal stuff just doesn't help me here. So there was 2 other things we talked about in your notes that I'd said they're not going to come up often, but when you need them, you need them. So those were taking the log of both sides, which we didn't need on today's practice quiz, and factoring. If it's got 3 terms like this that equal to 0, you probably need to factor it. So e to the x times e to the x gives you e to the 2x. When you multiply things with the same base, you add the exponents. You could do a -8 times a +1 to get -8. And then of course make sure the outer part of FOIL combined with the inner part of FOIL combines to be -7 e to the x. If you don't want to do guess and check, product sum will still work on this method. Same product sum method we did last semester. And now, since this times this could be 0, I could set this equal to 0 and maybe get an answer or 2. Or this could be 0. Set it equal to 0 and I might get an answer or 2. So each of these now look like really basic examples of the first 3 or 4 questions I did. Undo minus with adding, undo adding with subtracting, switch the forms. This is 6 questions in a row now where you needed to switch the forms. I would prefer you say natural log of 8 over here. And over here, you're going to be tempted to say natural log of -1, but what's wrong with this? Right. You can have negative answers, and you can have 0 as an answer, but you can't have the log of 0 or the log of a negative. It's just saying e to what power gives you -1, and there's no number that does that. So that's extraneous. I didn't do anything wrong. It just doesn't actually solve the original problem. So the only answer was natural log of 8. Now again, as a practice quiz, this is almost a little unfair, just in the sense that I didn't tell you to study for a quiz, and you probably didn't finish all of your practice from 3.3 book assignment yet. I'm about to give you more time on. But I still think since we have 2 practice quizzes, this gives you some indication of what your weaknesses may be, what skill you didn't try to use enough, all of that kind of stuff. So, if you don't have questions, bless you, bless you. If you don't have questions, you have the rest of class to finish up that book work we started last class. It was a little bit too long for most people to finish in class, and I told you you didn't have to do it for homework because I could give you more class time. But if you do have anything you'd like me to go back over or anything you'd like clarified, go ahead and tell me what that would be now, please.
Do you mean on the practice quiz or the book assignment?
On the practice quiz. I don't mind doing book questions too. I just don't have a book yet, so I'll go grab one. None of these on this practice quiz you want me to talk about a little bit more or ask a specific question about why I did something, or? Okay. Again, I don't mind questions from the book assignment either. I just don't know if it, number 70, sure. Okay, so somebody in my 8A class asked me this one, and at first glance I thought this probably couldn't be done by hand. I read the directions and it said do it with a graphing utility. So basically if you graph this as one line and graph this as a second line, the x value wherever they intersect is going to be the solution. But then I read the directions and it said verify your result algebraically anyway. So then I knew it was possible to do by hand. So I think the key to this question is you really need to add this over. And again, I didn't think of that at first glance. But now this looks like that question, the middle question on the right side of your practice quiz. These are both natural logs separated by add or subtract. So we could condense these. And I multiplied those and just went ahead and distributed. Switch the forms. Now, this is a quadratic, so anytime you solve a quadratic, you want everything on one side set equal to 0. 99% of the time, you can solve a quadratic with factoring, but this is one of those times you can't. So, I think we talked about one last time where you needed quadratic formula. So, quadratic formula is not like a big part of the quiz or anything, but it is good review. So make sure you know what A, B, and C is, what the quadratic formula says, and then plug in accordingly. That would be 2 times 1. Bless you. And as long as you plug it in the way the formula says, there's really not much else you can do. Negative times a negative becomes positive. 4 times 1 times e squared would be 4e squared. Oh, except, actually, man, that's pretty tricky. So quadratic formula is going to give you 2 answers. But I did notice if you do -1 minus this divided by 2, that would be a negative number. And when you try to plug that negative number in here, that part's going to be extraneous. So it should really just be the plus version only. So again, if you do the graphic thing that they ask you to do at the start, graph this, there's only going to be one time where they intersect. There's only going to be one solution. And that decimal is the exact same as this. So, yep. Just out of curiosity, was it that you didn't think to add this over and condense?
No, I got pretty far and then I got stuck when you put them all on one side.
Oh, okay, yeah. Yeah, if it doesn't factor, then quadratic formula is the only one that always works. So, John?
Could you do 40?
Sure. Let me look at it. Bless you. 3 to the x squared equals 7 to the 6 minus x. Okay, so thinking about our practice quiz, and I just went over 6 of these question types with you. There was like 4 of them. Undo, add, subtract, multiply, or divide at the start, end, and switch the forms. I can't do any of that here. There was one I had to deal with the fraction at the start. Doesn't apply here. One where I had to condense at the start. Doesn't apply here. One where I had to factor to start off. Doesn't apply here. There's only one other thing that I told you in your notes, and it's just that it doesn't come up often. The only way, and this is why I had to put it in your notes, the only way to move forward on this question is to take the log or natural log of both sides. You have to make sure you do it to both sides to keep it balanced. But the reason why this is helpful is now this is an exponent on something I'm taking the log of, so he can come down out front. This is an exponent on something I'm taking the log of, so he can come down out front. And I still have a few steps to go, but the logarithm stuff is over with. I mean, it's going to kind of carry on through the steps, but I don't need to use any other log properties. Natural log of 7 is just a number. I don't know what the number is. It's somewhere decimal, but I can distribute that. Just like the last question that was asked, this is a quadratic. The biggest exponent is a 2. Don't get creative in solving a quadratic. Move everything to one side, whichever side you prefer. Set equal to 0. 99% of the time, it's going to solve by factoring. But, gosh, even if it did solve by factoring, those natural logs just make it so messy that I don't know if I'd do factoring even if it did factor. You'd have to look at the coefficient of x squared is a. The coefficient of x would be b. And the constant would be c. And as scary as this looks, since this stuff isn't really going to combine together anyway, it's just going to make my answer scary looking, but it's going to be easy to do. Plug this in for b, plug this in for b squared, plug this in for a, plug this in for c. I'll change, it was minus and negative, so I changed that to plus. All over 2 times a. And really the only simplifying I can do is these two. 6 times 4 is 24. So let's plug it in as it looks.
Will we have any questions requiring us to use the quadratic formula or quiz or test? Or?
Not off the top of my head, but I mean, I think we would consider that to be fair game. Again, quadratic formula should be the most important formula that you guys got out of Algebra 2, so it's the only way that always solves a quadratic, so. At the very least, I would make sure that you at least knew what the quadratic formula was so that you could plug it in if you needed to. So. And I'm sure I've mentioned this 100 times before, but those of you doing calculus next year, the hardest part about calculus is pretty much anything you've ever learned is fair game in calculus. One question might expect you to know some geometry formula. Another question might expect you to know SOHCAHTOA ratio. Another question might want you to know quadratic formula. The next question might want you to know logarithm property, like expanding or condensing. And that's all mixed in with the calculus content. And it's not unit circle, comes up a lot. So usually when students struggle with calculus, it's not usually the calculus concepts or the couple calculus steps. It's usually the consistently adding fractions together correctly and factoring out GCFs even though it's not obvious, and doing log properties, and occasionally quadratic formula. I mean, that came up just this week, so it's nice because in calculus it all comes together and you can actually work some much cooler real life examples of stuff, but it is also increased difficulty since they just pretty much throw everything at you. So okay, does anybody have any other book questions that are ready to go? $64. Okay. Okay, so the first part of the question, I'm not going to go over that part, but it is a good skill for you to have. Just like the lecture I was giving you about calculus, like calculator things are important too. Knowing where this and this equals, sometimes in calculus you can just do this in a calculator. You could graph this, you could graph this, do second trace, calculate the intersection, and you can get an approximation, or 8 or 9 decimals accurate of the solution to this. But algebraically, which is more important to me because that's how you get the exact answers, is I can undo this times 6 from both sides. It's in exponential form, so I'm going to switch it to logarithmic form. And that should be the hardest part there, because now I can just subtract the 1 over and multiply both sides by a -1. So if you type that into your calculator and see the decimal, it would be the same decimal that would show up if you graphed this as one line and this is one line and did the calculate intersect. It would be the same x value. So again, if you only need to be 8 or 9 decimals correct, using your calculator is fine, but if you need exact answer, you got to be able to do the algebra here. Okay, I'm going to switch the screen here, but you guys still have about 32 minutes. So, ideally, I'd like you to finish up this bookwork in that 32 minutes, and I don't intend for you to have any real homework other than turning in some of these assignments. 101 was the 3.3 book assignment, 103 is your 3.4 book assignment, and 104 is this first practice quiz. Those are just turning those in is the only thing I intend for your homework to be. But again, that kind of depends on how productive you're being with the book assignment. So on Thursday, it'll be a pretty light class. I have one more practice quiz for you, and then you'll have some time to study, and then we'll have the quiz on Friday. I feel like I should point this out, even though this is pretty obvious. You've got the quiz on Friday. That's like, I don't know, 20 to 30 points, but those are minor points like most quizzes are. And then next week, Tuesday, we'll review the quiz. Thursday, we'll take the test. The test is over the same 2 sections that you're quizzing on. So if you put in the appropriate amount of time and energy before the quiz on Friday, then you should need to spend very little time practicing and reviewing before the test when it shows up as a 50-point major assignment. Just doing it correctly early should help your grade and be the same amount of work. So, okay. So go ahead and keep on working on that. I need to go start a copy real quick, so I'll be back in just a second. But then any of the book questions you guys have, I'll be happy to help.